So first off, what is React, right? So I told you guys to bookmark this page, and the main page is a really good summary of what React is. First off is declarative, meaning that you only declare things that you need. And React is just a simple library. So you don't need any sort of tools or software. You just need to incorporate the library inside of your system. But the only reason why React is different than most libraries like jQuery or anything like that is it goes off of another paradigm. You have to develop in a different way to React. Say, for example, with this picture, when you design a web page, right, you design a whole page with a nav bar, footer, forms, whatever goes on a page, you design the whole page yourself. But with React, you do design the page, but you don't design the whole page at once. You design them components at a time. So a nav bar would be a component, the form would be a component, the buttons would be another component, etc. So you're designing stuff component-wise. This is good for a couple reasons. The first reason is what happens when something breaks on this side, right? Then your whole page breaks. But what happens when something breaks on this side? Then only that thing will break. That makes debugging a whole lot easier and makes your page itself more functional without any errors, and it's more functional. Something else that React is that it's a one-way data flow. We'll get to that once we come there. And it uses a thing called a virtual DOM. So the reason why we're using the virtual DOM, because the DOM itself is pretty slow. Because if we use the DOM itself, it will take some time to load, because you have to load everything on the page before you load the page. And then that goes with all of the logic and all the styling to it. So the virtual DOM, the difference is that it's very different. Remember, DOM is the document object. So it's what the user sees and interacts with. With the virtual DOM, it's actually a copy of the DOM itself. Think of it as a blueprint. So a blueprint to what the DOM should be, component by component. And that way, it's a lot more faster because it renders components at a time instead of the whole page. It's a much more faster load time. Something else that React uses is JSX. Essentially, all JSX is using JavaScript inside of HTML. And once you learn React, you can learn a whole bunch of other things. And it's already something all of you know. It's based off of JavaScript and ES6, something we've been going over for the past few days. But once you learn React, you then can learn React Native. Learn how to build mobile apps or anything mobile. That's based off of React. The only thing difference is you're dealing with a different DOM. You're not dealing with a website, right? You're dealing with the user's touch, swiping, all of that. You can do VR with React 360. It uses technology of React to do virtual reality and immersive experience. And it's all React. You can also do some gaming kits. You can build your own games and combine them with the React Native and put them on the App Store, things like that. React hardware. I saw a case where they used React to program a crossbow to fire a crossbow using React. And they can send a satellite through React, they can build robots with React. It goes a long way. So once you learn React, you essentially know every single one of these. So that's essentially what React is, and I'll show you what it can do in a bit. But let me give you some motivation of why React, right? Why React instead of just still using Rails, instead of using Angular or Vue or Ember? Those essentially accomplish the same things, but why React specifically? Well, besides the things I mentioned, it's the most trending thing so far. is that on average, people that master React earn 6 digits in salary per year. So it's a very growing trend. Not only that, if you didn't know, Stack Overflow does their surveys with other developers, and they ask what popular technologies do they use. As you can see here, mainly it's JavaScript. So make sure you know your JavaScript, you know your SQL, etc. Then for technologies themselves, React is third compared to Vue. So it's rising pretty rapidly. So that's a new trend that's coming up. And it's almost taking over throughout everything. And if you want to learn more about React, there's something called React Rally. React Rally is a whole conference just about the topic. It's in Salt Lake City. The tickets get sold out quickly. So if you want to attend, be sure to sign up with the early bird that's coming up soon. So that is React Rally. And they just talk everything about React, what you can do with it, and all of that. Talk about the new upcoming technologies with React, GraphQL, all of that. Cool. So that's what React is, and that's the motivation. How we'll be using it is we're replacing our MVC model with Rails. With the views, we're replacing that altogether with React. So we'll work with Rails. Okay. Awesome. So I can go on and on about React, but instead of me telling you, let's actually see what it can do. So if you all go into your terminal, change directory to wherever you need to be, and then let's create our React project. So yesterday, we downloaded Create React app, and it's a boilerplate to create all of React's projects. So similar to how you do with Rails. When you do a Rails new, it creates a whole Rails project for you. Create React app does the same exact thing. If we were to build this from scratch, it'll take maybe weeks to get your mind wrapped around Webpack, and then JSX, and then configuring Babel, and then React. So that's not time well spent. So we're just using the boilerplate, and this has Webpack already configured for us in Babel and everything. So to create a React app, you do create React app, and then the name that you want it to be. So today we'll be building an account, React account. Something that counts things. Yes. And then go ahead and press enter. And this comes with some dependencies. It comes with React, it comes with React Doc, React scripts, all of those. And this is using, instead of Ruby gems, it uses NPM packages. Same sort of concept. It's just using libraries to import their code. That's just a message from the developer to make sure that we are developing. It also comes with some stuff to start your server with Yarn, all of that, and we'll get there. So the thing about React is that you would need to run a server to see your stuff. And I'll show you how to do that. So first, let's cd into counter. And then let's open this up into our default text editor. And let me show you what it comes with. So it's not as much as it is in Rails, thankfully, right? That has so many files and folders. But it comes with the main things that we need. And keep in mind that what React does is just the views. It doesn't deal with the database or anything like that. So it's just a presentational component of a web page. So we'll start from the bottom top. So we have our getignore. That's where you put things for get to ignore. Package.json. So this is the equivalence to Ruby gems, to the gem file itself. There's also a lot of other things as well, like information about the app itself. You can see that the name is here, the version, any dependencies. This is where you would add your packages if you have some sort of styling packages, anything like that, you would put them at the app dependencies. And then scripts, when you run your scripts, it will run either your server or anything like that, and then just more information. README. The README comes predefined with Create React App. You can update it to your own README itself. And this is just all information about Create React App. And then the yarn lock is similar to the gem lock. It's just all of the libraries that it downloaded when you went through and ran your package.json. As you can see, there's Babel here that translates your code into something readable in browser. And then there's Webpack, and etc. So those are the bottom ones. Node modules, you would never have to open this in your life. So all it is all of the libraries that you need are inside of the node modules. So those are all the dependencies, dependencies. That's what node modules are. It's just all of those libraries in that folder. So that's why you always need to ignore them in your getignore, and you don't need to manipulate them. And never push up your node modules to GitHub, because if you scroll down, I'm only at F, and there's a lot. So keep in mind, never push your node modules to GitHub. Yeah. We'll take a look at that. And then the public, this is similar of the layouts and the application inside of Rails. Essentially, all of your React app will display on this HTML page. So you can set everything here, and this line here, this is where all of our React and JavaScript will be injected to, in that root div. And then there is a no script for those weirdos that don't have JavaScript. But yeah. Then favicon information. And then finally, this is the source folder. This is where we'll be doing our development. And this is really where the meat of the project is. So we have our application.js, testing. We won't get to that, that's extra. Some style sheets, index, and service workers. And I'll explain what each of these are as we get to them. The main thing is that we will be developing in the JavaScript files. So in the index.js is one of them. And then our app.js is another. And then we'll be making our own JavaScript files as well. Okay. So let me show you how the project is currently. And there is a hierarchy of how everything works. So the highest point, the most apparent of element inside of this app is the index.js. Index.js. everything inherits from it. That will then get displayed at the root, and that's the parent class. Second off is the app.js. App.js. That's the child to the index.js. And it inherits everything that goes on in there. But before we develop, let me show you how to run your server. And then we'll break things down line by line. So to run your server, all you need to do is yarn start. Yarn start. That runs your React side server. And by default, same as Rails, it does it with localhost 3000. And straight out of the box, it comes with this. It comes with a slow animation. Edit this, and then I'll like. To see where this code is, you would go to your source folder, app.js. This is where this code is. Is that you have your div, you have your logo, edit this to reload, and then what does this look like? Yeah, it looks like HTML with a little bit of extra syntax, right? Instead of using class, we're using class name, and so on. We'll come back to that. So that's how you would run your React servers with yarn start. So let's start from the parent class all the way down to the child. So the parent is the index.js. So anytime you want to use React, you would have to import it from the library. So import React from React. That will give us access to everything React has, plus Babel, plus JSX, everything. And that's important if you want React inside of this file, or else it will just be a JavaScript. Second off is this React DOM. Now, this is different depending on what you're working with. If it's native or if it's hardware, this will be different. Since we're just working on websites, React DOM just implements all of the website things once. So instead of, since we're using the virtual DOM, instead of creating a div, we're using a React div. So it'll be React dot div. And that creates a virtual DOM for us. That's what importing that library does. This line is how you implement styling into your application. And since this is the parent class, this style sheet will go through the whole entire app. So this is app-wide. Next up is any sort of components that you want. In this case, we want to import app from /app, which is another React component that we're using. Then finally, we have a service worker. Service workers are used for production caching. Some people say you need it, but to be honest, you don't. So you're more than welcome to delete this. And even if we push it up to production, we don't need a service worker. There's no use for it. Okay. So now we get into this line. So this is how React knows what to display. So key term React DOM renders the component of app component. And then where we're rendering it is inside of the document get element by ID. That's from JavaScript with the ID of root. As you remember, if we go to public index.html, this div has an ID of root. So everything that is on this left side will be displayed on the right side. That's what our line is saying. Okay. So far, so good. It's a little bit different. Now let's see what app is. So app comes with stuff that is already predefined with creating React. We're still incorporating React, but in this case, we need to incorporate something else called component. So to know that a class is a component, you need to implement and import component inside of your project and have your class extend component. So it knows that this is a component class. Then this is just all styling. Then for every component you're doing, it needs to return or render something. It needs to render something. If it's logic-based, you have to return something. If it's just presentational, you still have to return something. So when in doubt, you have to have something displayed. Now there's two types of components, and we'll get to what that is. So the first component starts with the key term class. So class, and then the name of the component, app. And as you can see, this app is also the same name as the file itself, exact same casing. So those have to be the same. Extends component, and then brackets. And then to render something inside of the key term class, you would need a render and a return. So return returns an HTML element. Renders just renders the return statement. Now, here's the caveat. If you want to use this in other places, something that we learn is we need to export it. So at the bottom of this component, we see that we have a term export default app. That way we can import this in other places. You can see that since we export app here, we import it here for us to use it. So that's why we need to import and export for every component we have. Okay. Now, since this is JSX, the attribute of class gets transformed into class name. That's because if we just do class here, it will get confused of the JavaScript class. That's why the class attribute is class name in React. And everything is camel case. You can use JavaScript with the brackets. So let's begin building our app. And this is essentially what we see when we launch our server. We can see this. So if I manipulate this of hello world, save, you don't need to refresh because it's a library load built in. And this is hello world. And that's the thing too, is that when you're updating items, it doesn't reload the page. It actually just reloads or re-renders the component itself. And that keeps it from breaking, but it might also cause issues as well. Okay. So let's build our application. Let's clean up our stuff a bit. So we don't need the styling stuff, so we can delete that. And then let's do this. So each one, the class name of app title. Counter, we'll call this React counter. And then P with some pseudocode. So this is where we will have the counter. Let's give it a class name of app intro. Nope, preference. Okay. Essentially, all this is HTML. The only difference is, again, the attribute is class name instead of class. But it means the exact same thing. And this is what it should display. It should display at each one and at each. So there's a few things when you're rendering something. So let me show you this. You don't have to follow along. If I delete this div, I get an error. I get a JSX element must be wrapped and then closing tag error. So when you're rendering something, you need to wrap the things that you're rendering, if there's more than one, inside of a grouping tag. That's either a div or a section, anything to wrap everything together, or else you'll get this error. And this is just the way that React works, is that when it's doing a div, or in this case, we have an h1 with key tag, instead of just rendering out both of those, it does a React h1 and a React key tag. And then that causes a syntax issue. Because it's React and then React instead of the h1 and then. So it's the way that it's built. That's why we need to wrap things when we render them into a enclosing tag, which is a div. So you have more than one element, just wrap it within a div. And then there is a better solution. And I'll get to that maybe today or tomorrow. Okay. So I mentioned that React is a different way of developing. Because one way you're breaking stuff up into smaller components, and the other way is how each of those components work. So first off, is that we have two key terms we should learn. Is that every component has two things. It has a state and it has props. Think of state as each component's way to store items. So just think of it as storage. You can store objects, you can store an array of items that's based off of this component. And then we'll get to props. Let's just focus on state. And we will also use our React tools as well. So let's open it up. So Option Command C, and then we'll have our React tool. And this will show you some items. So far, it displays what we have, right? Nothing new there. So to implement a state, let me show you what you could do. Is that you could have a constructor props, super props, and then you can define state. So this means that this component itself dot state equals whatever you want to store. And it's always an object. So constructor props is super, those inherit everything that's coming to this app. So anything from the parent to the child, that's with super.props. And then to do state, you just define that it is this object or this component dot state equals to some object. So for now, let's just have our value equal 0 for our counter. So let's update our counter. So instead of having, this is where the counter will be, we'll have the bracket to be this dot state dot value. So this dot state dot values refers to the storage of this state up here of value. And what is value initialized as? 0. This should be key value pairs, right? Since it's a hash. Instead of value equals 0, should be the key of value and then the value of 0. So the equal sign. So this should be value colon 0. And that renders onto the page. Oh, I zoomed in, and that might be, yes. So with our counter example, we need to somehow manipulate our state, right? Because that's where we're storing the value. So I'm going to scroll down just a bit, and we'll have a few buttons. We'll have first button. Oh, cool. Button of plus to increment, and then we'll have the same one to decrement. So essentially what we want to do is anytime we press on these buttons on the DOM, it will update the state of value to accordingly. So that should increment it, this should decrement it. Okay. So that means we need some event handlers. So this would have an on-click of a function from this object called increment. So on-click is the event handler. If you click on it, then it will do some function. In this case, it will do from this component and then the function name of increment. Then we'll do the opposite for decrement. So this dot dec. Okay. So let's create those functions. And we'll use our syntax wheel. So with increment, it's with the parentheses, and then do something, and then we'll do the same decrement. And do something. So to manipulate state, you would need a term from React itself. So what we want to do is we want to call this object set state camel case, and then the key value pair. The key is what you want to manipulate. The value is what you want to manipulate it to. So it'll be value colon this dot state dot value plus 1. So we're just adding 1 to the original value. You could do plus plus, but that will mutate the state itself. We don't want it to be mutated. We just want it to increment. So what does that mean for decrement? How would that look? This set state value colon this dot state dot value minus 1. So let me show you this in action. Well, when we press on it, what do we do? An error, right? So the thing about functions is that you would need to bind them to the component themselves. You can't just create a function and then use them inside of the component. You would have to bind it to the component itself. And you can do that a few ways. The first way is inside, right under your state, inside of your constructor, is you would do the key term this dot increment is equal to this dot increment dot bind this. So that will bind this function to this component. And then we'll do this exact same thing but with decrement. I just copy it and paste with Command Shift D. So just duplicate the line for that. So we need to bind it to the component itself. So now that we bind it, you can see that we can manipulate the state accordingly to the bind. And something you may notice is inside of your web tools, the updates here, it will update the state here. So this is a view of your current component state. And we're looking at the app component currently. And then the state is with the value of -1. If we increment, it increments, and it changes the state. So we're manipulating the storage for that component. Something else that you probably don't notice is that this re-renders, right? Anytime you change the state, it will rerun the render function. So change state. That's why you're seeing a change of number here. Because since state is updating, then the view should also be updating as well. And it's super quick. You didn't even notice it. It's part of the React reconciler, and it's very fast and efficient. And to see this in action, I'm gonna put a console log. So instead of increment, we'll do console.log. This.state.value. Just to see how everything works. But what's different about it? 0. Yeah, 0. It starts off with an offset. So the thing is that with set state, it runs asynchronous or at the same time as when we render the top. So even though at this point, the state is still 0 at first, it's already incrementing to +1. That's how fast and at the same time it is. But this probably looks a lot messy, right? You don't want to type bind this for every function when you have like 1 million functions. You would have to write that 1 million times. So let me show you another way to bind. And we'll refactor this a lot. So we can comment this out, and then we'll refactor. So with our constructor and all that, we only bring it in if we need to. So we don't need to bring it in if we don't use it. So that means that since we're using state in this particular instance, the only thing we need to bring is state itself. And instead of calling this dot state, we can just say state and have that equal to our object of value equals 0. And then if you want to add more things to state, separate by comma, key value pairs. And this is still valid because ES6 allows trailing commas. But then how do we bind something without this extra syntax? Well, let me show you. So to bind items, you can just use an anonymous function. So with increment, we'll do an anonymous function and then the syntax here. And then we can bring in what we need to here. That means we can do the same thing with decrement. So decrement change the state to here. So this also binds the function to this component as well. And it's just a little bit more syntax just on the function itself. So it's really up to you. Would you rather write this and this, or just this, right? It's a different way. And since it's written this way, you can also require parameters. So if you have any parameters here, they can go here too. So that's cool. And it still works the same way. Still changes the value inside of state. So just remember, when you're writing functions inside components, you would need to bind them to the component itself. And you can do that with two ways. This is probably the easiest and fastest way. Okay. So the thing about components is that reusability. Because as you notice when we develop in Rails, especially with edit and new, we're using the exact same form, right? So instead of creating a component for each of the individual things we need, just create one and reuse them in the cases we need. So let's do that. Let's say that instead of one counter, we can have two counters, or more of any number of counters. The long solution is to write this again, put it in another component, right? But let's just write it once and use it multiple times. So let's refactor. So we'll get more organized as we go. But let's create a new file, and we'll call this capital C counter.js. Your component name should be capitalized. Counter.js. And since this is a React component, we always need to import React. I'll do it this way, React from React. Then you can define what the component is. In our case, it's called a counter, capital C, and we want to extend the React component. And then before you type stuff inside of your class, let's be sure to export it. Export default counter component itself. Okay, so that's the main thing you need to do. A couple things you may notice is that we're calling React.component here, while in app.js, we're just calling component. That's because you can write this line two ways. You can write it like this way, but you need to import it on the top with that syntax. Or if you don't want to import it like that, you can just say your React.component. It means the exact same thing. And you'll see them both ways, whether it's in lecture or on Stack Overflow. They mean the exact same thing, but you do need them. So the extend represent. Yes. So it's going to the React library, and it's pulling the component element we're using. Awesome. So since we're refactoring, essentially what we want to do is we should take the logic that is from our original counter and put it in its own component. So let's take this. Let's take the state and the function, and then we're just going to put it here. And then afterwards, all of our components need a render and a return. So it needs to display something. So render, return, and we'll have a div, and then we'll put items in there. We'll put our own counter in. So after you do that, let's take our counter in there. So it will be this. We'll cut that and then paste that. So the buttons and then the p tag is all I'm transferring. So we are done with the counter. All I'm doing is I'm just moving everything over into its own. So I'm moving all the function, the state, the buttons that actually represents the incrementing and decrementing, and where you display it itself. So that's the counter JS. So I'll come back to this page because we need to clean up the app.js. So we actually don't need what we have there. We can still keep our header. We don't need any of the state stuff. You can comment it out if it's good for notes, but I'm just going to delete mine. And that's all we need. Is that within this component, it will just be a render and a return of what we need to display. So how do we implement our counter JS? Well, we have another component here, meaning we can do this. So we can have, we can actually put our counter inside of app.js. Since all of the logic, all of the HTML and JSX is already here, and we also export it here, we can then import it and use it anywhere on our page inside of our app. So inside of our app.js, if you need to use anything, you would import it. And in our case, we are using a counter. And this is from the path to the component. And since the path is in the same directory, then it's just /counter. /counter. If it's in the folder, it'll be /, the folder name. You don't need to include the extension, just the component name. And this should match up with this and this. That's where I'm getting counter from. That is where we're defining counter and where we're exporting it. That's what we're importing from the path. So now that we import it into app.js, to use it, it's as simple as making it into an element. So it will be counter and then self-closing tag. So now that we refactored, everything still works the same, right? But instead of rewriting the same code over and over again, let's just duplicate this a bunch of times. We can now see we have multiple counters. And the really cool thing is that if you press increment and decrement on one of them, it doesn't change the other. They're considered as different components, different counters. And if one of them breaks, then just that one breaks. It doesn't break the rest of the counters. It's pretty cool. So you can see how the scalability can increase with this flow. Is that all you need is just some templated code with some logic and how it displays. And then you're easy to duplicate that over and over again. And then with state, how that comes to play is that each and individual of these counters have their own state. That's why when we increment and decrement, it doesn't change each other's value at all. It just changes the counters. So this state has a value of 3. This counter state has a value of -2. They have 2 different states. They're considered as 2 different elements. Awesome. Any questions so far about React?
So you're explaining it.
Oh, that's the next topic. Yeah, we haven't got there.
Oh, so each instance of the class, so has its own state. It's basically it just refers to that particular instance. Right?
Yes.
So you can basically use this state, writing function.
Write functions, save data. You can actually save users inside of state itself. Display that information on the screen. Save it too.
I will not cover what else you can put in the state.
Yes.
So with where you can very basic value, right?
We can actually put objects and stuff too. So anything you can put inside of a hash, you can put inside of state. It will just be referenced how you would put it. Awesome questions. Any other questions? Sweet. All of the code is in Slack. So before we went on break, we saw what React can do for us. And we are introduced with the term of state. Essentially, all state is an object, right? It's just a hash with key value pairs. And the purpose of state is for storage. That's how we're able to use state. But we're treating it as an object. And all components have something called a state, which is storage, and something else called props. So if you look here, inside of our tools, it has state here, and then on the top it has props. So what exactly is props? And how do you use it in React? So props is shorthand for properties. These properties you want to pass down from parent to child. That's what props are. Is parent to child properties you need pass down. Parent to child. Not only that, is that the props are also read-only. You can't manipulate props. So essentially, we can pass things from the parent to the child with props. So how do we do that? So to add props from the parent class to the child class is, from the parent side, you need to define what the property is. Let's just say I'm going to call this color. It's better to be descriptive in this case than just random, right? You can't say X, like what does X represent? And then we'll set that equal to a value. Let's say the color is red. And we'll do the same thing for some of them. Well, let's change the color. We'll do blue, green, black, yellow. And then the last view doesn't have props. So you can pass props by defining the property with a key value pair. So that's how you would pass it down to the child, because as you remember, counter is a child path and path is the parent of counter. How would you use it in the other place? So let me slack this out. So here, if we look inside of our dev tools real quick, and we click on this counter, we can see that it has our state and also props. So it has a property of color, which is set to red. This is blue, green, etc. So this is based on each individual instance of the component. To use that is inside of our counter itself. Let's just do like an H1, and we'll call this like the name or the color counter. To access the props, it will be the key term, this component's props. And then you don't want the whole object of all of the props, right? You want to be more specific. You want to say you want the color prop. This color comes from this color being passed down from parent to child. So essentially the first one would be the red counter. It has props. So as you can see here, we have red counter, blue counter, green counter. And then the rest would just be empty because we didn't pass anything to those children. So that's essentially what props are, is properties that you want to pass down from parent to child. And we can have a little bit of fun with this. Let's actually change the color of each counter depending on their props. So let's do this. We'll do inline styling. We'll go over how to style in React. But inline styling, you would need 2 mustache brackets, and it would be camel case. So if I want to do the background color, it'll be background camel case color instead of the dash. And in this case, let's just have it be this dot props dot color. All we're doing is inline styling of setting the background color of this dot props, the color. The element, the property that we're being passed down from parent to child. Now we have colorful counters. Ooh, black is horrible. So that's state and props. State acts as a storage. All it is just an object. And props is properties you want to pass down from parent to child. It's freedom. Any questions about state or props?
So props are only that level instantiate.
Yes.
Only this one.
Yes. So if we want to do another prop, it would be like name equals Rick. That would be essentially another prop. And then if we look at the dev tools real quick, you can see that this, for a specific one, has a prop, color name. So to define props, you just pass it down from the parent to the child. To use it, you would use this component's prop, and then which prop you want to use. Excellent question. Any other questions?
So if I am not a class that inherits from the counter, I can define the prop that class on the counter.
If you pass it out.
Right.
Yes. We'll do that in our next example. Awesome. So let's wrap up what we just learned. So straight out of the box, React, creating React app comes with a full working React application for us. And with our index.js, that's our parent. That's where everything inherits from. That's where all the styling should be, all the fonts, everything should be at this level. At this level, we're rendering app.js, a component that's the child to index.js. And here, we're just rendering out multiple counters. Just backtrack a bit. When you are creating a component, you would always need to import React and then extend component. You can do that two ways. You can do that this way with this syntax, or you can do extends React.components. It's up to you, but those two are the exact same thing. Then all of the components need to render something. In our case, we have a render and return statement. And what we're rendering is multiple counters. Inside of our counters, which is our child, we're being passed props, which are just properties. And then we have some logic here. We have some functions that change the state. State is an object of where you store, in this case, values. And then we can use them accordingly. And if we want to use the counter, for example, in any other place, we need to define it here and then export it. You always need to export if you need to use it somewhere else. So if you want to import, always remember you have to export. And something else we learned is anytime that we're changing the state with this.state or we're manipulating the state, it calls a pre-render. So it calls this function again, pre-renders with the new information onto the screen and displays it on the screen. So when state changes, it calls this function again. Sweet. And that's how you make a React counter. Any questions? Pretty. It's not as bad as Rails first day, right? It's a lot more clear. Yeah. It's not as syntax heavy. Sweet. So let's get a little bit more complex. Not anything too crazy, let's create another application. So I'll zip the project up at the end of class. Be sure to Control-C out of your counter, and then we'll be building another React app. Okay. So how would you build a React app with our boilerplate? Create React app, and then the name of the project. Let me show you another way. So you can create an app this way, or you can do yarn create React app, and then the name of your app. Works the exact same way. This is a newer way to do it. This is where it updates to. But you can use them both. So yarn create React app, and then the name, or you can do create React app. Go ahead and press enter. Yes, yeah, don't press enter. A CD out of your counter. Oh, cool. CD into user. Let me go back to where I was. Give me 1 sec. Okay, so make sure you're in your desktop or wherever, or else you'll create a React app inside of another React app. You don't want that. So just go to the project and then just drag it into your desktop. That's the easiest way. So you we'll talk about that on Monday. We don't want to get too crazy too soon. Yeah, that to-do list. Sorry, to-do list. Short answer, yes. So this creates the exact same boilerplate for our application. This is new. So I guess you can't use capital letters now. So let's just use dash list then. I don't know why. I think that's a new update with Create React App. So I guess don't name it camel case or any capital letters when you're creating projects. It's a naming restriction from NPM itself. So I guess it causes conflicts with NPM. Okay. And I would plug in your power source because you are running a server and it's constantly updating and re-rendering every time. Sweet. So the flow here is create the app, go into the app, and then start coding. And it comes with the exact same thing. And I explained that in the first hour. Let's just get to coding. Let's just clean everything up. Inside of our app.js, let's delete our 2 imports that we don't need. And let's just have a pair of empty divs. So I know to-do list might be overkill for this, but it is a good learning curve. Essentially, since we're building an application, we're breaking things up into tiny bits, right? We have our to-do list, our form, and our item itself. Then we'll fill those out as we go. So you shouldn't build everything inside of one component. It should be separate components and then bring them all together in the main component, which is, in this case, your app.js should be your main component. Awesome. So what's state again? Yeah. Yeah, it's where you can store items. All it is just an object. So let's have a state. In our case, let's just have state be predefined to-dos. So it'll be an to-dos colon an array of objects. So ID of 1, name, and these are just key value pairs, right? Learn, Rails, complete, true. And we have trailing commas. And I'm going to duplicate this 2 more times. And then make sure there's a comma after each object. So to learn React and learn React router. And let's just change this false, false, and this to 3. So I just have predefined to-dos inside of my state. Data starting off. Now, what I want to have happen is when I do a yarn start and display my web page, I would want to display each of the to-dos. And this is just preference. I'm going to display them in a list type. So it will be wrapped in a UL, and each of those to-dos will be an LI. But what is each to-do in? Before that. So it's inside of a hash, and inside of array, and then another hash, right? So we would need somehow to iterate through it. So instead of doing it all in here, which you could, let's call a function instead. So it'll be this component, okay, dot render to-dos. That's using a function from this component. And then every time we create a function inside a component, what do we need to do? Bind, yes. And you combine it with this syntax. Awesome. So now we can grab our state, but more specifically, let's just grab our to-dos. So we're using a const to-dos, and we are destructuring it from our state. So as you remember, essentially what this line does is it does const to-dos equals this dot state dot to-dos. All in one line. Object destruction. So now that I can grab my to-dos, and to see what to-dos is, let's run our server. What's the key term? Yarn start. It'll take a while, and it'll also launch our React tools. As you can see here, we have our state. This is on the right-hand side. And then inside of our state, we have to-dos. And each of those is an object with key value. So that's what to-dos is. Since to-dos is an array, how do we iterate through all of them? Yeah, let's do a map. You can do a for loop, but let's do a map. So in this case, I want to return all of the elements. So return to-dos.map. Now we'll call each of these to-dos to-do. And then the function inside here is we will return a list item with to-do.name. So we're mapping through each of the to-dos. And then for each to-do, display each of those as an li, and display just the name. And then once you switch to your browser, it will display. But there is something to it. Check your console. It gives you a warning. So if it's an error, it will say error. If it's a warning, it's the same color, but it will say warning. So warnings are different than errors. If you have an error, it will break your code. And it will also break your page. But with warnings, it's just information. Something that you should do, best practices, things like that. So that's the difference between warnings and errors, even though they may look the same. But for this particular type, this warning says that each child in a list should have a unique key prop. That's because in React, even though that we specify that it has a different name, different ID, complete all that, React treats them as the same thing. So we need a way to identify that the first one is different than the second. That's what the key, the term of key. So inside of our li here, we add an extra attribute of key equals something, a unique identifier. In our case, we can just pull from the to-do ID. So this would be to-do.id. And that will get rid of that warning. So again, if you're looping through a list item, for React to know that they're all different, you would need to incorporate the key attribute. Awesome. So let's look at what we have so far. So far, we have a state with an array of to-dos, predefined to-dos with key value pairs, which then runs a render, which has a div that launches a function of render to-do. And inside of that function of render to-do, we're mapping through the to-dos inside of our state itself and displaying each one of those with a name and having an identifier with the key of the ID. Okay. So far, so good. So to be honest, we can build the whole to-do list here in this component. But then when something breaks, we don't know specifically where things are breaking. So let's break out our to-do list even further. So let's add in another component. So in our case, we have index, and then app, and then we'll add one more. We'll add this. We're taking the logic out of this and putting it into list. The purpose of list is just to display all of the to-dos. So we're refactoring our code. So let's create a new file. And instead of creating it just in the source folder, let's be more organized. Because if this is a bigger application, you can lose files pretty quick. So we'll create a new folder, and we'll call this to-dos. And inside of to-dos, we'll create a new file, which then is capital list.js. So, like I said before, there's two ways to create components, and there's two different component types. What we have here is stuff with logic and state. You can hear the term differently, but how I will refer to this is a logical component. Anything that needs logic or needs a state, you would need the key term class, and that would be a logical component. The second component is a presentational component. Let me write notes. So this would be logical component. Anything that requires any sort of logic, or if you need a state, that would be a logical component. And it will start with a key term class, have all your logic, extends component, render, all of that. Second one is called a presentational component. Anything that you just want to display. You don't need any logic to display it. You just need to display it onto the page itself. No logic. This looks different. You would still need to import React from React. And you don't need to also use component business. And this is what we learned yesterday, is using cons as a module. So key term cons, the name of our component, list. We're passing props if there are any, and then like that. And this follows the same convention of when you create any sort of component, you would need to, if you want to use it in other places, you would need to export default list. Presentational component. It doesn't start with a key term class, doesn't have state, doesn't have any sort of logic. What goes in here is just JSX, just things you want to display. Yes. Nope. We'll get into when you use curly brackets or parentheses. So with the parentheses, anytime that you're rendering something, like in this case, we're rendering this div, that will be a parentheses. In this case, we're rendering a li, that will be a parentheses. For presentational, that should also be parentheses because we are just displaying something onto the page. For brackets, really depends. Anytime that you need JavaScript, you would require brackets. And then if you're using a logical component, it would be with brackets. But yeah, that's an excellent point. Is that with presentation components, we're just displaying something, so that should be parentheses. Cool. Let's clean up our code. Essentially, we want to bring the list here. So let's just have, if we're rendering something, it has to be encapsulated in some sort of grouping element. And in our case, is a div. Let's just have a h2 of the props.name, and then ul props.items.map item li key item ID, and then item.name. So we're just bringing the logic out we have and putting it in its own components of list. So that means we need to update the list. And I'll come back to this component. Well, let me put it in Slack. All of this is just changing it just a bit from our app.js. So instead of doing this, we can comment that out. Comment all this out. I'm just going to delete it. You can comment it out. JSX comments are different. I'll look those up during break. But there aren't the // And then if I want to use the list component, what do I need to do? Export it first, and then that way we can import it. Exactly. So import list and the path to list. So to get to list, you need to go to a folder. So / to do's / L list. So import list. And that's the relative path from this file to the component. And then lower, we can just do our list element and pass it props. So we'll do the name of to-do list. Items is another prop, and this would be to-dos. So we define two properties. First is the name of the list itself, and items, which are the to-dos. This dot state to-dos. Because we're grabbing it from state. Okay. So since we're passing from parent to child the property of name and then items, so name is to-do list, items is the array of to-dos. That means that it will display the name here in the H2, and then inside of here, the props of items, it will display it with the LIs. Still should be the exact same. But if we look at our list elements, we are passing in props of the array and then the name itself. So with the presentational component, you can just say props. It knows that it's from props. Or you can destructure it. So instead of saying props, you can say the actual props itself. So you can do items and name, which means that this could be refactored to just name and then items. So you can do props, or you can actually do the name of the props. So that's what goes in this parentheses, is anything that's being passed down from parent to child. It's similar to how attributes work. So let me show you that again. So originally we have props, which means all of the props coming in. Then we're displaying the props name, the array of items. But the other way you can do is, if you clean it up, you can bring in the props themselves of name and then items. Okay. Everything in the return, essentially. I think the JXX commenting is like this. Something like that. I need to double check. But it's super weird. And it's not native to VS Code, I don't think. So that's how we would update the code for props. And it actually makes more sense like this, right? We're bringing in items and name instead of just props. Gives it more of a visualization. And let's see if we can update this. So let's destructure to-dos. So instead of saying this.state.todos, we can just say to-dos. So we're making a constant of to-dos, and we are pulling to-dos from this.state and having that as a variable. So that way, we can just use to-dos. Because what if we have more things in state, right? What if we have name and state, and account and state. You don't want to write this.state.account, this.state.todos every single time. So you can just object destructure here. Continue on with key value pairs. So we have name, count, still valid. You can just say name and account. Okay. So the flow of this is we learned two new things. We learned that there's two types of components. We have a logical component, meaning that if we need to use state or some functions, it should be a logical component. It should have a key term of class, and in mustache brackets, it will look like this component. Our child class is a presentational component. This doesn't need any sort of logic. It just needs to display something to the DOM. Key term cons, and then we are using a parentheses here. And we're just passing information down through props. There is a caveat to this, is as you remember, inside of the first presentation when I introduced React, is that when we pass it down props, it's one way. It's only a one-way data flow. So it only goes from parent to child. You can't go back upstream. You can't go from the list to the app. There are solutions to it, but we'll present those later. But for now, you can only pass things from parent to child. So that means that if I have another component here, form, which is coming out, and I'm using the same to-dos, instead of having both to-dos here and here, that will be redundant. You need to have it from parent to child. So add a higher order component. HOC, higher order component. All of our to-dos is in a higher order component, which is app.js. The highest order is our index.js. That's where our fonts and styles should be. Awesome. Any questions about the different components, props or state? Still a relatively new concept. And it's okay if you don't get it all too. Yeah. Awesome. A bracket, but if there's only one, you can encase inside of parentheses. And that should solve that error. So let's have a way to add to-dos onto our application. And it will be a child of app and sibling of list. And there's a purpose for that. We'll go into it. So inside of our to-dos folder, let's create another component. We'll call it to-do form.js. Now, every time you create a component, you need to ask yourself a question. Is this a presentational component or is it a logical component? With the to-do form, you need to display the form as well as a way to submit the form. So what component does that sound like? Logical? Absolutely. So since we need to store information, we need state. We need to do some sort of logic to submit the form. So we need logic, and then we also need to run it. So that's a logical component. So with that in mind, we can import React, as well as component from React. And to start off, since this is a logical key term class, to do form extends component. And then before we forget, and since we want to use this in other components, we should export default to do form. And for now, we know for sure that it always has a render and return. That's the given. You need to return something inside of the component. Okay. So let's fill out our form. So in JSX, we just need to encapsulate with some sort of HTML element. In our case, we can just use a form element. And we'll put our input here. We'll give it some attributes like required, placeholder, and to do. That's our form so far. It's just a single input with the required field and a placeholder. Let's implement this in our app.js. So in our app.js, I want to use to do form. I would import it. So import to do form. And this is from this /todos folder, and then to do form component. And that's just the relative path. Then here, just right under the list, let's wrap everything in a div so we don't get that error. Move it up, and then we can incorporate our to-do form here. Yeah, sure. So again, we wrap things in a div because of JSX. You need to have an encapsulating element. And then we're just calling our component with that syntax and importing it at the top. Okay. You might see it better on your screen, but now we have a form. So if we fill this form out, press enter. It doesn't behave like we want it to. first off, what happens when we press enter? What happens? Yeah, it refreshes or it reloads. We don't want that. The reason why is every time the page reloads in React or refreshes, it loses the value of the form before we can grab it. So we want to prevent that from happening when it's being submitted. So inside of our form, let's do an attribute of onSubmit. And this will be this handle submit, which is a function. What do we have to do with functions? Bind it. And that by default with forms, it refreshes the page every time you submit. So on submit, let's prevent the default. Let's do e.prevent default. The default is to refresh and dump all of our data. Now you're probably wondering what E is. E is our event. Let's actually take a look at it. You don't have to do this, but I'm gonna console log. And we'll take a look at what that is. Oh, cool. That should be here as a parameter. So when we submit a form, you can see that is a event. And it comes with anytime you submit a form, and you can use anything that he has. In our case, we're using prevent default, but you can stop pagination, timestamp, all of that. So it's the event itself of when you submit a form, in this case. Awesome. So now when we fill something out, press enter, it doesn't refresh. It's amazing. It doesn't dump all of our values. So the next step is that we need to grab that value somehow, right? And store it into somewhere safe. What's a good storage for components? The state. So let's store what we have so far inside of the component state. So let's do this. Let's give this a value. We'll give this a value of name. And then the name itself would be name. And let's have a onChange to be a function called this dot handle change. This dot handle change. So, like we discussed, we want to store the input value. In this case, we're referring to that value as name inside of our state. So with this state element, all that will be in it is just a name, and by default should be an empty string. So you can set default to. So this name should reference that one. So technically, this should be this dot state dot name. But what's the easier way to do it? Object destructure. Also, so we'll do name here equals this dot state. That way, instead of calling this dot state dot name, we can just say name. So we're pulling name, setting that as a value in our state. Now, anytime that the input changes, we fire off a handle change function. So let's create that function. So with this function, same conventions, you would still need to bind it. Hash rocket, and then what we want to do is we want to change the state to whatever the user types, right? To whatever the value is. And we can reference the value with name. So this set state, this component set the state of the name equal to e.target value. E.target is the form itself of what's being changed. And then the value is, in our case, the name of the city. So we're changing what the state value is to what the user types in. Now, this took me like a few weeks to wrap my head around because it's super confusing. There's names multiple places. But we'll see this in action. Let me Slack this out. Yes. Yes. We are also passing in the event here. Thank you. So to see this in action, we go into our React tools, go into our to-do form, or you can type in the component you want to do. So in this case, I want the to-do form. Has a state of name so far. Right now it's an empty string. But how our code is set up is anything we type in, it will set the state and change it to whatever the user types in. And it will change accordingly. Asynchronous because set state is. So that's how we can grab the values. Is that we have to have a place to store them, and then have a way to identify what we're grabbing. In this case, we're grabbing the value of name. And then whatever the user types in, set the state to the name to whatever the user types in. That's how it changes. The thing that got me confused is this name here and here are completely different than this. Because this name itself represents the name that's in the state, right? This name here is an identifier that what the input is represented. So in our case, we can say to do would work the exact same way. That's just a name thing. Awesome. So that's the next step is that once we prevent the default, refreshing, and then we grab the data with the handle change. Now we need to display it here, all right? We need to display it onto the list. So the thing is that the way our app is set up, form and list is synchronous, right? the only way that we know how to pass information down is with props, and that requires a parent and a child relationship. So that means that if we want to transfer data from this to this, from component to component siblings-wise, that's when we use a higher order component. We would have to do it inside of app.js and then pass it down to the props. So that's our next step. Is that inside of our app.js, we will be doing a function called add item, and that will add the item onto list.js. So let's do that. So here we would have from props a function called this.add item, and it will be brought in with this.state.name. So we want to add the item with whatever's in the state currently, whatever the user changed. Then afterwards, we can just reset the form. So this.set state for name to equal empty string. Okay. So this is just prepping what's to come. So now let's define our add items function from our parent, which is app.js, and then pass it down to props. So app.js, and then this is where we can define our function. So you can pass anything through props. You can pass objects, you can pass values, but when we're passing here is a whole function itself. So we call it add item, should be singular. Yep, singular. We'll bind it, and this requires a parameter, and the parameter is the incoming to do. And what we want to do is we'll grab our to-dos from our state. So we'll destructure it. So const to-dos, this dot state. And we would also grab a new to-do. We'll make a new to-do with the object of name equals incoming to-do ID is this dot get unique ID. We'll create that function, and then complete would be false. And then all we need to do is update our state, right? Because our current state only has 3 to-dos. We would update our state to have all the previous to-dos in addition to the new to-do. So we'll do set state to to-dos of an array of our new to-do with the rest of everything inside of to-dos, right? That's the rest operator. So with this function, we're taking in an incoming to-do, incoming name, grabbing the to-dos from the state, creating a new object of to-do. The name would be whatever comes in there as a parameter. The ID will get there. And then the complete would be false, a whole new object of to-do. And then we are setting the state of to-dos to our new to-do that we just created, and then everything else that's inside of that to-do. So now let's define this function. Is that we need to have a unique ID for every single time we create a to-do. So this is another function, unique ID. We'll bind it. All it is just, it will return a math.floor of a few things. So it will be 1 plus math times dot random times 0x 1000 10,000 to the string of 16 to substring of 1. What does all that mean? Well, I just went online and see how I can generate a random number. That's all it is. So listens this, listens that. So that would generate a unique ID for every single to-do. So now that we have our function here that adds the item onto our to-do array, we can then pass it down through props, not only in lists to use the same exact to-do array, and also to so then with props, we can just do add item, passing in a whole function of this dot add. And let me slide this down. Okay, let's walk through this. So if we go inside of the form, what happens is that once they fill things out, as it changes, it will update the state to whatever the user types in. As soon as they hit submit, it won't refresh. It will then do this.props.add item. And that's defined at the parent element. So we'll go into app.js, do all of this, which is grabbing the to-dos, making a new to-do with the information added, and then create the state with everything put together. go back into the form, run the this.set state main. Let me clear out. Then after that, it goes back into app, state changes here, which means there is a new element, a new object inside of to-dos. That means that render refires, and then list also updates. So now list has a new element of to-do. It'll map through all of the items again, display them. So that's the flow. So now you can add to-dos inside of your application. But what's the problem that we have? Yeah, as soon as you refresh the page, it doesn't save. That is, React by itself only works in the browser. So it only relies on the browser's memory. So anytime that we create a to-do, this saves in the browser's memory. That's why we need RIPs, right? We need to display all of this on the React end and then store it in a safe place. We need to store it inside of a database inside of RIPs. That way, when we add to-do items and refresh, we don't lose all of that. So that's what we'll get to on Monday. But for today, we're just relying just on the memory of the browser. Awesome. So let's see if we can do a little bit more CRUD actions. Because we have add, we have view. Let's do an update. So let's just update individual to-dos. So when I click on them, it should change the complete, and that should also change the style. That means I need to break down my list even further. So I'll have one more component. Oh, it's my markers. So inside of my list, I would have another component to do, single, which I would display each individual to do itself. So for now, let's create a new component of to-dos. Inside of the to-dos folder, we'll make a new file, call it to-do.js. And in this case, we need to make a decision again, right? We need to make a decision of, is this a logical component or a presentational component? So the functionality of the to-do is it will just display individual to-do itself. What component is that? Presentation. So we would still import React on React, but this time we don't import component. And since it's a presentational, key term const, to do is the name, and we'll have props. Let's make sure we don't forget those curly braces this time, and then parentheses. And then let's also export default to-dos. To-do. Okay. So for the props, let's say we are expecting an ID, a name, and a complete, because that's everything a to-do has. With that, we can display something. So within the LI, we can just display the name in between the LIs. have the style depending on the complete. So if complete is true, then more logic here. Else styles dot to do. So if it's true, then it will inherit all of the styles from to do, as well as the styles that we give it, which is called complete. So that's just a ternary condition. Depending on what complete is, if it's true or false. If it's true, then it will be same styles with addition of if it's a true styling. But if it's false, then it should just have whatever, just whatever comes with it by default. So that's inline styling. And then let me show you the component-wise styling. I like to put it on top. Other people like to put it on bottom. Up to you. So we'll create another constant. We'll call it styles. And we'll set this equal to an object. And with this object, it will be key value pairs. So the first key is to do, and this is just CSS properties and values. So the cursor will be pointer. And then after a comma there, we can do complete. This would be color, gray, text decoration, yeah, sure. Line through, and then trailing commas. What is this? Did that generate from somewhere? Yeah, we don't want that. Yeah. That was weird.
Did that same thing happen in
No. No. That's creepy. Yeah. I don't remember that appearing. I watch Haunting of the Hill House, so I'm a little bit paranoid when it comes to these things. Awesome. So with this to-do component, we're taking in the props of ID being complete. And depending on the complete, we are changing the styles accordingly. If it's complete, then it should have both of these styles. If it's not complete, if it's false, then it should just have the first style. That's the logic that comes through here. So that means we should update the list to display this component to do. So let's just import to do. But where's this located at? To do. Because it's in the same directory, it should be // If it's in a different directory, // directory / your component. So instead of displaying a whole li, let's just display to do. Oh, yeah, taco. Is that, wait, that's not how you spell taco. Okay. To do. And then let's update this. So we'll pass it the key. And then the name would be that complete would equal that. But do you want to write that every time? What if we have another problem, right? That line just gets a lot bigger. So let's not write it this way. So you can keep that as notes, but I'm gonna refactor this, and instead of saying each prop, or yeah, essentially what each to-do has, I can just do this, the rest, right? It'll be dot dot item, 3 dots. So cleaning up our code, so displaying each individual property. Let's just say the rest and call it items. So as you see here, it's already updating the styles. If it's complete as false, it will then do the styling logic accordingly. So let's just finish up with our complete and then we'll wrap up. Okay. So every time we click on it, we'll have an update of toggling it from complete to not complete. Because right now it's not doing much. So that will be in the to-do. And then inside of our LI here, I'm going to have the style be on a new thing, new line, and we will have an on-click function. And then we would do this. So passing in anonymous function of to-do, click with the ID. So where does to-do click comes in? Well, technically, you could refactor this into a logical component, like put to-do click in this component. But as you remember, all of our to-dos is in our higher order component. So we should pass down props and tell it what to do. So in this case, the parent of to-do would need to pass in props of to-do click. To-do click is a function. So that means inside of our list component, we need to pass down that function. So not only do we pass in items, we'll do to-do click equals the function of to-do click, which means that the parent for this component needs to pass this down, to-do click, to have that defined. And what's the parent of our list element? App.js. So we'll go into our app.js, pass it down to our list element of to-do click equals to-do this dot to-do click. And then we can define it here. So to-do click will require an ID. And let's bring down all of the to-dos from our state. So const to-dos equals this dot state. That's object destructuring. And then we will do this dot set state, a much more complicated one because it is an update. So in here, we would map through all the to-dos and change the one that we're looking for from complete to not complete or just toggle. So with that case, with to-dos, it will be equal to the to-dos.map. We'll reference each of those as to-do. And then if to-do is equal to the to-do ID, which is equivalent both value and type to the ID that we're looking for, then return everything that that to-do has, as well as changing the complete to whatever it's not. And then return to-do. And this is now in Slack. So inside of our to-do component, we need to update our to-do, which means we need to do it in the parent in a higher order component, which is ReactJS, which then looks through all of the to-dos, looks for the one that we're looking for, and then change what needs to be changed. Else, it will just return the to-do. There we go. It will return the to-do. So we're passing this function down to list, then down to to-do to use. Okay. So we're passing it through our list, and then list is then taking it and passing it to to-do, and then this is where we're using it. So now we have an update. Awesome. Now there is a filter portion of the lecture. I won't get into that today, but if you want to look at it, it is inside of the lecture. And it's just manipulating React more. I'm just gonna stick to the current CRUD actions. So when we are passing down props to a component that doesn't use it, in this case list, to a component that does use it, which is to use, this causes an issue, right? Because we're doing something unnecessary. We're passing down props from all the way downstream. This is from parent to child. But list is never using it. This problem is called prop driven. Because essentially we're passing things down to components that don't need it, all the way down to where it does need it. That's an issue. A solution to that is with Redux and the context API. That's a whole nother topic for a whole nother. But for now, just know that that does cause an issue of when we do pass down props all the way through. Another thing is that as soon as we refresh, it comes back to its original state. So we need something to store all of our information as we do it. That's why we need Rails. We need a backend to store all of our information. So React is only in charge of the front end. Okay, so new things that you learn what React is. You learn that all React is splitting things up into components. And each component has its own state, which is storage, props, which are properties that can be passed down from parent to child. And then there are two types of components. You have your traditional logical component, anything with logic, anything with a state. And then you have your presentational component, anything you just want to display. And then the rest are just ES6 and JavaScript stuff, object restructuring, and manipulating stuff. Oh, and the reason why we're doing this function here is that besides a database where it generates a new ID for you, we will have to do it ourselves. So instead of doing it ourselves, let's just have our database do it for us. So once we have our database, we can eliminate that portion. I'm going to go into a little bit over time because I want to go into most like errors you'll encounter. So the first error you would encounter is this. This failed to compile, attempted to import some sort of component, but does not contain a default export. That's exactly what it means. It means that you didn't export a component or you imported it incorrectly. So where you would go is you would go to that component that's trying to import, see if it's exported, and also see if it's the correct path or the correct name. That's something you'll encounter a lot of as an error. And then there's a few more, and then we'll handle those as we come. But yeah, that's basically all React is. It's a very powerful tool to manipulate the virtual DOM. It's super fast, super responsive. And since we now have a to-do list inside of our app, we can create more lists with more forms. So it's really scalable from here. Any questions about it?